so this is the chemistry lesson video for section 11.3, and this is part 2. So we're going to learn how to predict whether a precipitate will form when you mix chemicals together. So one thing you'll want is a copy of your solubility rules. Now, I've given you one in class if you're in class with me, but if you've lost yours, you can find a copy on my website. It just looks like this, or you can Google them. However, I will tell you, in the many different chemistry books that I've had to use throughout all of my education, sometimes they may be slightly different. And like, for example, the rules I gave you say soluble or insoluble. Some rules, they'll have a moderately soluble category and things like that. So I'm just going to use this. So like I said, if you're finding something different online, it just means they used a slightly different set of rules. But the majority of these rules are pretty cut and dry. So you can predict whether a precipitate forms by using solubility rules. So let's just go back to remember what a precipitate is. If you mix chemicals together and it remains see-through, I'm going to say clear, but it could have a color, like Windex you can see through, but it's blue. But it remains where you can see through it. It remains transparent. That's probably a better word to use. Then a precipitate did not form. However, sometimes when you mix liquids, you will form a solid in the liquid. It'll look kind of cloudy. Sometimes if it's white, it looks milky. It might look murky or muddy. So that's what a precipitate looks like. So if a substance is soluble, then it will dissolve in water and be aqueous. So it will not form a precipitate. Remember, a precipitate is a solid that forms in a liquid mixture. If a substance is insoluble, then it will bond with another ion and will be a solid, and that would be a precipitate. So here, this only has soluble substances. This one, it has something that's insoluble that's forming that precipitate. All right, so this is just the same solubility rules I held up for you. So, you know, if you don't have your own copy, you can screenshot this and just use this. All right, so alkali metals, which are your metals from group 1, not hydrogen, they are considered soluble. Ammonium ions are soluble. Compounds that contain nitrates are soluble. Chlorates are soluble. Now these two are where it gets a little tricky. Sulfates, which is SO4, are normally soluble, which means they'll be aqueous, except if they bond with one of these. Okay, so what I like to do is take this and say this is insoluble. So what that means is, like, let's say we have Li2SO4. Sulfate is normally soluble, and with Li, because that's not an exception, it is soluble. So that would be soluble. However, let's say we have CaSO4. SO4 is normally soluble, but this time it's with Ca, so it would be insoluble. That's what the exceptions mean. Some of my students have trouble figuring out what except means. So it means that anything with sulfate is soluble unless it's one of those things. All right, the same thing happens for chloride ions. So Cl is normally soluble, except when it's with silver, lead, or mercury. So again, if you want to, on your chart, circle those and then put insoluble. And then at the very bottom, we have a list of just a bunch of insoluble ions. And so those are carbonates, phosphates, chromates, sulfides, and hydroxides. All right, another thing that you may want to do is, a lot of people, when I say group 1 alkali metals, they forget what they actually are. And so then when you see something like lithium or potassium, I'll say, oh, is it on your solubility rules chart? And you'll say no. Okay, so what you may want to do is actually just write what they are. So we have lithium, sodium, potassium, rubidium, cesium, and francium. Okay, so you may want to actually write what the group 1 alkali metals are so you don't forget they're actually on the solubility rules chart. Because if you notice, every element or ion is not on here. If it's not on here, you just have to find what is on here to be able to tell what's going to happen. All right, so first, let's just determine whether things are soluble or insoluble. All right, so the important thing to know is, if any part of the compound is soluble, then the whole compound is going to be soluble. So it doesn't matter. Think of it this way. Soluble equals aqueous, which means it's going to break apart into ions. Insoluble means it's a solid, so that means it's going to stay together. So think about it as a couple. Let's say you have a couple who are dating. One is soluble and wants to break up. One is insoluble and wants to stay together. What's going to happen? They're going to break up. It doesn't matter if one of them wants to stay together. If somebody wants to break up, they're going to break up. Okay, so if one part is soluble, the whole thing is. All right, so let's look at NH4Cl. So if you look on your solubility rules chart, you can find NH4, and it tells you that NH4 is soluble. So that means it would be aqueous. All right, so NH4 is soluble, so it's going to be aqueous. You could have also looked at Cl. It's soluble, and so it would have been aqueous also. But once you find one soluble thing, just quit looking. All right, for BaSO4, Ba is not in its own category. SO4 is. SO4 is normally soluble, but it has some exceptions. So if you look at your solubility rules chart, Ba, I know you can't actually see this, but remember, you should have your own. Ba is an exception. So instead of being soluble, it's going to be insoluble or a solid. So BaSO4 would be a precipitate, whereas ammonium chloride would not. Ammonium chloride would look like this, whereas BaSO4 might look like one of those. All right, so our next one, we have Na2SO4. Now, again, a lot of you would look at your chart and say, oh, well, Na is not on there. And you would immediately go to SO4, which is fine. You can still find the answer, but Na is on there. It's a group 1 alkali metal. Group 1 alkali metals are soluble. Then you don't even have to worry about looking at exceptions. There weren't any exceptions for those. So that means it would be aqueous, so no precipitate. All right, our next one is calcium hydroxide. So calcium is not on your polyatomic ion sheet. It's not on that either, but it's not on your solubility rule sheet, but hydroxide is. It's at the bottom. All right, and hydroxide is insoluble, so that would be a solid or a precipitate, so it would look like one of these. But it could be a different color. All the calcium hydroxide is just white. All right, next one, K3PO4. So this one gets a little tricky. K is a group 1 alkali metal, and so K is soluble. However, if you look at the bottom, PO4 is insoluble. So here we have a soluble and an insoluble. So what's going to happen? Well, remember what I said. If somebody wants to break up, it's going to break up. So this one would end up being soluble because K is soluble. Now the problem comes where if you don't remember K is a group 1 alkali metal, then you would say, oh, well, K is not on there. You would just look at PO4 and then you would think it's insoluble. Okay, so you got to remember those group 1 alkali metals. All right, next one, magnesium nitrate. Magnesium is not on your solubility rules chart, but nitrate is. It says nitrate is soluble, so it would be soluble or aqueous. So these last two would both not form precipitates. All right, our next one's AgCl. Ag is not on there, but Cl is on there. It says Cl is soluble, but Cl has some exceptions, and Ag is one of those exceptions. So instead of being soluble, it's going to be insoluble or solid. And then our last one, nickel is not on your solubility rules chart, but chromate is. It's at the bottom, and it is insoluble or solid. So our last two would form a precipitate. Okay, so remember, if one thing's soluble, the whole thing's soluble. The group 1 alkali metals are the actual group 1 on the periodic table. They are on the chart. And then last thing to remember is soluble means it's going to be aqueous. Insoluble means a solid or precipitate will form. So let's look at how to actually predict in a reaction form. So the rules for predicting precipitates are you're going to switch the ions and balance the charges to form the products. So I'm going to give you some reactants. First you have to form the products, then balance the equations, and then tell me whether the products are solid or aqueous using your solubility rules. Alright, so these are going to be most of the time double displacement reactions, and so we already did double displacement predicting products back in section 2. So the only new thing that we're doing is then telling if the products are solid or aqueous. Okay, so if you weren't very good at doing the predicting products in section 2, here is another chance for you to see me do it again. Alright, so remember, for double displacement, you're going to have two compounds that are paired up, and we're going to swap the two positives. All right, so first I like to write the charges. So hydrogen is +1, chlorine's -1, Ag's transition, but NO3 is on your polyatomic ion sheet, it's -1, so Ag has to be +1. All right, so I'm going to take it and I'm going to swap my two positives. And if this is confusing you so far, you need to go back and watch 11.2 again. All right, so now H is going to bond with NO3. I'm going to write the H first because it's the positive one. So H, positive, NO3, negative. Remember, NO3, nitrate's all one thing, so I don't do anything with the 3. I just bring it on over. Now Ag is going to bond with Cl. I'm going to write Ag first because it is the positive one. So Ag positive, Cl positive, so I don't need any subscripts here. All right? Once you do that, you need to balance the equation. So I have 1H, 1H, 1Cl, 1Cl, 1Ag, 1Ag, 1 nitrate, which is NO3, and 1 nitrate. So again, we've already done this in 11.2. The new part is, see how I told you both of these are aqueous? You have to tell me what the products are. So you have two options. You can have one aqueous and one solid, or they can both be aqueous. You're not going to get two solids. So if you think they both end up being solid, just double check your solubility rules. All right, so on your solubility rules, H is not on there, but NO3 is on there and it says it's soluble. Remember, soluble means it's going to be aqueous. It is not going to be a precipitate. Okay, so remember, soluble means aqueous, insoluble means solid. A lot of you want to put the S for soluble because they both start with S. All right, so then our next one, Ag, is not on your solubility rules chart, but Cl is. Cl is normally soluble, but Ag is an exception. So instead of being soluble, it's going to be insoluble, which means it's a solid. So what I know now is if I mix HCl with AgNO3, I'm going to get a precipitate, and it's going to be AgCl. That's what that means. All right, so let's look at another one. Okay, and there's just all my work for what I did. All right, so let's look at this one. Maybe pause the video and try it on your own. Just see what you can do. I'll assume you've done that. All right, so again, we have double displacement because we have two things paired up. So I need to swap my positives, but I'm going to start by writing my charges. So C2H3O2 is acetate. It's -1 on your polyatomic ion sheet, but there are two of them. So that's really -2. So lead has to be +2. Remember, lead can have more than one charge. Lithium is +1, it's in group 1. Chlorine is -1, it's in group 17. So, because this is double displacement, I'm going to swap the two positives. So now, Pb is going to bond with Cl. But I have to bring over those charges. So I have Pb +2, Cl minus, so I've got to balance my charges by bringing down that Cl. Now, lithium is going to be with acetate. Now, this 2 came from the fact that acetate was bonded with lead, which had a +2 charge. So I'm not going to bring this 2 over. Now I'm going to bring this 2 over because it's part of acetate. I'm going to write lithium first because it's the positive one. So I have lithium positive, C2H3O2 negative. So again, notice I did not pull the extra 2 because that only happens when it bonds with lead. So next step is let's balance this equation. Ooh, this one's kind of weird how it's on multiple lines, but we'll do it. So we have 1 Pb, 1 Pb. I have 2 acetates, but here I just have the 1 acetate. So I need a 2. 1 lithium, 2 lithium, so I need a 2. And then 2 Cl and 2 Cl. So here's the new part. Like I said, we've already predicted products in the last section. So the new part is telling what state of matter the products are going to be. So Cl is normally soluble. However, it has some exceptions, and lead is one of them. So instead of being soluble, it's going to be insoluble or a solid. Lithium is a group 1 alkali metal. Those are soluble, which means it will be aqueous. So in this reaction, if I mix these two chemicals together, I will get a precipitate, and it's going to be lead 2 chloride. All right, so hopefully you at least got part of that right, or the whole thing. All right, and then there's just my work broken up for that one. All right, so let's try it one more real quick. So again, pause the video, try it on your own. Even if you're making little mistakes, that's okay. This is the first time you've ever done this. I don't think you do this in any other kind of class. All right, so remember, it's double displacement because I have two compounds that are paired up. So I'm going to start by writing my charges. So NH4 is a polyatomic ion. It has a positive 1 charge. That's on your polyatomic ion sheet. Cl has a negative 1 charge. Ba has a positive 2 charge because it's in group 2. Nitrate is on your polyatomic ion sheet. It has a negative 1 charge. And so now I'm ready to swap my positives. So NH4 is now going to bond with NO3. But notice it has the 2 because it was bonded to barium. It's not bonded to barium anymore. Okay, so I'm going to keep the 3 because nitrate is NO3, but I'm going to get rid of the 2. I'm going to write NH4 first because it's the positive one. So I have NH4 positive, NO3 negative, so I don't need any additional subscripts because my charge is already canceled. Now, barium is going to bond with the chloride ion. I'm going to write barium first because it's the positive. So barium positive 2, fluorine minus 1, so I need to cross that 2 down so that the charges are balanced. Next thing is, don't forget to balance the entire reaction. So I have an ammonium, NH4, and I have 1 ammonium, 1 NH4. I have 1 Cl, but here I have 2 Cls, so I need to put 2. But now I have 2 ammoniums, so let me go back and fix that by putting a 2 here. I have 1 Ba, 1 Ba, I have 2 nitrates, and I have 2 nitrates. All right, so it's balanced. So the last step is we need to determine, is it aqueous, is it solid, what's going on here? So if you look at your solubility rules, NH4 or NO3, you can look at either of them. Both of them are soluble. So since they're both soluble, it is aqueous. So that's not going to be a precipitate. Next, Ba is not on your solubility rules chart, but Cl is. So Cl is normally soluble, but it has some exceptions. However, Ba is not one of the exceptions for Cl. So it is going to be soluble, so it's also going to be aqueous. So what this means is if I mix these two chemicals together, everything's going to remain aqueous, so I will get no precipitate. Okay, remember, it's okay to get no precipitate. A lot of people, they want to redo it because they just assume that if you get no precipitate, something must be wrong. Remember, it's okay to have 1 precipitate or no precipitate. You shouldn't have 2 though. All right, so hopefully this wasn't too bad. And like I said, just for time's sake, I'm going to do the section assessment as a part 3.